The very last section that we will do for lesson 1-2 will be questions 17 through 20 to finish out the lesson. Here we have Missings discovered another pattern in the artifacts. He noticed that when triangles are used, the triangles were all equilateral and often multicolored. In an equilateral triangle, all three sides have the same measures. They've drawn a couple of figures for you. They have the figure of the one triangle. Here we have 1, 2, 3 triangles. Here in figure 3 we have 1, 2, 3, 4, 5 triangles. Let's take a look to see what it says. Number 17 asks, attend to precision. Determine the perimeter of each figure if the pattern of each side of one triangle measures 1 centimeter. So what it's saying is, what would be the perimeter if this was 1 centimeter, this was 1 centimeter, and this is 1 centimeter. And then you would do the same for figures 2 and 3. On the next on the next page, it says Missing found that he could determine the perimeter of any figure if the pattern uses the expression 2n plus 1. Use Missing's expression to calculate the perimeter of the next 3 figures in the pattern. Use the table below to record your calculations. So you're going to include figures 1 through 3 from the previous page, and then the next figures continuing the pattern on. It says create a sequence to represent the perimeters of the figure if the pattern does the sequence have a common difference, and if so, identify it. If not, explain. Lastly, it asks you to graph the relationship, and it says be sure to label your axes and the scales on the y-axis. All right. I'm going to have you debrief. I'm going to have you work in your partners or with your table mates for the next 10 minutes to complete questions 17 to 20. So go ahead, pause your video, and good luck. All right, I started off by answering question number 17. I said figure 1 has a 3 centimeter perimeter. Figure 2 has 5 centimeters. Please notice that we count this one, this one, this one, this one, and this one. We do not count these because they are not on the outside perimeter. We only count all the outside edges. So again, we have 3 centimeter, 5 centimeter, and 7 centimeters. It says over here in question 18 that he uses the expression 2n plus 1. Well, let's just take a look. Does that work for the problems we already did? Well, I got 2 times 1 plus 1. Well, 2 times 1 is 2, plus 1 is indeed 3. Let's check out this 2 and 3. 2 times 3 plus 1. 2 times 3 is 6. Plus 1 is indeed 7. So it looks like that pattern's going to hold up. So I continue to work it out for the figure number 4, 5, 6, and 7. Then in number 19, I went ahead and wrote my sequence. Now remember, with our sequences, we use the numbers of our perimeters. So I went 3, 5, 7, 9, 11, 13, and 15. And then remember, I added the dots at the end to show that this pattern continues. Now, remember, if it has a common difference, that is where we have 2 consecutive terms and the difference between them is always the same. So if you notice, it goes plus 2, plus 2, plus 2, plus 2, and so forth. So my common difference is 2, so therefore it does have a common difference, and I've identified it. Let's take a look at what that would look like in my graph. Whenever I went to graph this, I said my figure numbers were across the bottom, my perimeter in centimeters was along the side, and I did a count of 2. I didn't feel like it was necessary to go by anything bigger, and if I only went by ones, I wouldn't have been able to plot enough. But if you can notice, we start with 3 here, and then it goes 5, 7, 9. Notice what kind of forms along here. It's going to be a line because we have that common difference of 2. So I want to make note that whenever I graph this, I did not graph the line. I just graphed the points because we can't have a figure 1.5. So it doesn't make sense to have this piece connected because there's not a possibility for a figure 1.5. Therefore, this is what we call discrete points versus continuous. And we'll get into that a little bit more in the class, but just remember the fact that discrete versus continuous. Continuous is where you can draw the graph without picking up your pencil. Discrete is individual points along the way. On to your last debriefing question.